In 8.6, we're going to learn about how to factor a polynomial in the form of ax squared plus bx plus c. In 8.5, you'll learn how to factor a polynomial in the form of x squared plus bx plus c, where the coefficient here is positive 1. So now we're going to learn how to factor a polynomial when the coefficient is not positive 1. So to write this in factored form, meaning as a product of two binomials, you will end up with two binomials that would look like this: a1 times x plus p and a2 times x plus q. So let's look at this backwards. After I expand this using the FOIL method, a1x times a2x, I get a1 a2 x squared, and a1x times q, which makes a1qx, and in the inner a2px, and in the outer p times q. Okay, let me further explain this. For the first term, we can't really do anything to that, so just recopy it. For the second and the third terms, we can factor out the x and make a1q plus a2p as our binomial factor. And pq, can't do anything, just recopy pq. Now we can refer a1 times a2 to the coefficient a here, and a1q plus a2p to the coefficient b, and p times q would be your c. So therefore, your a would be equal to a1 times a2, and your c will equal to p times q. And we can reorganize the factors a1, a2, p, and q, and use this method called the magic cross to factor polynomials in the form of ax squared plus bx plus c. That is when the leading coefficient a is not positive 1. So we're going to write a1 here, a2 here, p, q. Okay, and then let's look at this example. 3x squared plus 11x plus 10. So now I'm going to look at the leading coefficient here, 3. So a will be my 3. And I think I need to think of two factors, a1, a2, that will make a positive 3. So that could be 1 times 3 or 3 times 1, it doesn't matter. So I'm just going to do 3 and 1 here. Now I'm not going to worry about negative 3 times negative 1. That just makes my life too complicated. Okay? And then for 10, my c will be 10. And then I could use 1, 10, or 2 times 5. Now your goal is to apply this magic cross so that when you multiply a1 times q and add a2 times p, you would get a value that will equal to the b coefficient in ax squared plus bx plus c. So if I put 3, 1 here, and I match this with 1 and 10, 31, that makes 31. That's way off, too big. So I wouldn't use the factors 1 and 10 because 10 is too big. So maybe it is 2 and 5. Okay, this takes practice, okay? So I'm going to do 5 and 2. And I notice that 6, I like to put an L here. 3 times 2 makes 6. 1 times 5 makes 5. 5 plus 6 makes 11, which equals to the b for this polynomial, 3x squared plus 11x plus 10. Okay, so now that I have my factors, I can factor this. Okay. So now I'm going to write 2 binomial factors. I'm going to take 3. I'm going to put it right here. I'm going to multiply that to x, and I'm going to add 5 because it's positive 5 here. Now, here, I'm going to have to take 1 and multiply by x, which is just x. And then I'm going to add it to 2. So in this case, I do not suggest that you use the pattern that I taught you in 8.5 because of the fact that we have a coefficient of a other than positive 1 here. And so once you find your factors, you need to pay attention to the signs. Since these factors, a1, a2, p, and q, are all positive, there's nothing to worry about. And basically, if you draw a line through this, and you can look at this. This is one factor. Let me use black. This is one factor, 3x plus 5. And this is the other factor, x plus 2. And just a review, if a1q plus a2p equals the value of b in ax squared plus bx plus c, then this polynomial can be factored as a1x plus p times a2x plus q, as indicated earlier here in the key concept. So note that the positive and negative sign of b does matter, okay? And this will take practice, and it's a little bit harder than 8.5. Okay, let's do some guided practice. This is the same problem as before, and I just want you to try it again. So here I listed out all the possible factors. But usually when I look for the factors of a1 and a2, I just look at the positive numbers because my a here will always be a positive, okay? So you could put 1 here and 3 here, or vice versa, it doesn't matter. And then for the other one, since this is a positive 10 here, I wouldn't worry about any of the negatives. And I said earlier that 10 is too big of a number. So by number sense, I wouldn't use 10, okay? It's too near 11. And then if I look at the pair 2 and 5, how would I know which one to use? So if I don't know, I might have to do a little guessing here. 3 times 5 is 15. 1 times 2 is 2. 15 plus 2 is 17. That's too big, okay? So as you get better with these, you'll be able to tell more quickly which one to use or which pair. So it has to be 2 and 5. 3 times 2 makes 6. 1 times 5 makes 5. Add these together, and 11 will be equal to the coefficient of the second term of the polynomial. So by looking at this horizontally now, this is your first factor. Now, a1 would be the coefficient, x plus 2, 3x plus 5. So just to be clearer, the 1 is here. The 2 goes here, well, the positive 2. And the positive 3 goes here, and the positive 5 goes here. And you just add the x's next to your a1 and a2. Okay. Okay, for this next one here, to the right, I see 2. So I'm going to just simply use 2, 1. And then I see a positive 3. So I'm going to do maybe 1, 3. And 2 times 3 makes 6. 1 times 1 makes 1. You add these together, you get positive 7. But our coefficient here is negative 7. So maybe we need to change the signs here. Okay? So this makes negative 6, negative 1, negative 7. And now we have our factors ready. So 2 times x minus 1. 1 times x, I'm not going to write the 1, and then minus 3. And here is our factored form. Okay, and this for this next one here, I listed some factors, pairs of factors. So I looked at 1 and 6 to see if it works. 6 times positive 1 plus 1 times negative 5 makes a positive 1, so this one doesn't really work. And I'm going to do 1, 6 with negative 1, 5. 6 times negative 1 makes negative 6. Still doesn't work. So then 6 times positive 5 makes 30, which is too big. So I could cancel this one out. And the same goes for this one. This makes negative 30. 6 times negative 5 makes negative 30. Okay? And then I guess 1 and 6 is not a good choice. So I'm going to move on to 2 and 3. 2 times negative 5 makes negative 10. 3 times positive 1 makes 3. 3 plus negative 7 makes negative 7. Great, I found it. 2, 3, 1, positive 1, negative 5. Okay? And then I could double check again. 2 times negative 5 makes negative 10. 3 times positive 1 makes 3. 3 plus negative 10 makes negative 7. Okay, so I can find my factors. 2 times x plus 1, 3 times x minus 5. Okay, I'm going to do this a little bit more quickly now. 5 only has 1 and 5, and 8, well, negative 8, I'm going to have to consider 2 and negative 4. Okay, and then I noticed that when I cross multiply this, this would be positive 10, and 1 times negative 4 make negative 4, and positive 10 plus negative 4 makes positive 6, which is your coefficient in the middle. And 1, 5, and 2 and negative 4 are your magic cross pairs. Okay, and don't forget the second variable y. So your binomial factors would be 1 times x plus 2y. 5 times x minus 4y. So when you check with FOIL method, it works. 5x squared, negative 4xy, plus 10xy, minus 8y squared. So 5x squared plus 6xy minus 8y squared, which is your original polynomial. Okay, factor the trinomial. Note, factor the negative 1 when the coefficient a is negative for ax squared plus bx plus c. So here I have a negative 4, so I need to factor out the negative 1. So this becomes negative 4x squared minus 12x minus 7. Okay, so our goal is to make sure our a here is always positive. So just keep the negative sign on the outside and don't worry about it. So now we're ready to factor, and I noticed that my coefficient here is negative 12 and my c here is negative 7. So I could do negative 1, 7 or negative 7, 1, and I'm just going to work with these two pairs first before I check out other pairs. I'm going to use 4 and 1. And if you notice this, 4 times 7 is 28. That's too big. And then even if we use that, and then we take 1 times negative 1, it still makes the sum, which would be 27, which is still too big. So I think 4 and 1 would not be a good pair to work with. Try 2 and 2. 2 times 2 makes 4. So 2 times 7 makes 14. 2 times negative 1 makes negative 2. And then the sum of these makes a positive 12. So we found it. 2 and 2, negative 1 and 7. As I said, with more practice, you'll become quicker with this. And then the reason why I'm explaining this very slowly is because some of you might be very new to this. Okay, so here, 2x minus 1, 2x plus 7. And don't forget the negative sign. Okay, let's do another practice with the -1 coefficient. Factor out the negative sign. Okay, and now this is easy because you have a +1 coefficient here. So remember the negative sign, positive, negative, x plus, x negative. And I see that I can use 9 and 20. And then because this is a positive here, I need a +20 and a -9. So the 9 would go here and the +20. So -9x plus 20x makes 11x. Okay, so this is quite tricky here. Don't refer back to the original polynomial and get the +20 and the -9 switched around. Okay? Okay, and this next one here, for 4, I could use 4, 1, or 2, 2. And with +15, I could use 1, 15, or 3, 5. But I wouldn't use a 15 here because 15 is so big. So I will work with 3, 5 here according to experience. And then let's pair it with 4, 1 first. 4 times 5 makes 20. 20 plus 1 times 3 makes 23. That's doesn't work, basically. And even if we flip this around, 4 times 3 makes 12, and then 1 times 5 makes 5, and that's 17. It still doesn't make 16. So we wouldn't use 4 and 1. So let's look at 2 and 2. 2 times 3 makes 6. Okay, I'm going to use this one here. 2 times 3 makes 6. 2 times 5 makes 10. Great. This is equal to 16. If you use the other pair here, 2 times 3 makes 6. 2 times 5 makes 10. It also makes 16. So it doesn't matter if it's 3 on top or 5 on top. Either way it will work. Okay? So now we're ready. I'll just use this one. So we're going to take 2, and it's an n here, 2n plus 5, and take 2n again, and plus 3. Okay, and for this next one here, we can do 3, 1, -14, 1, -2, 7, or -7, 2. Now, I wouldn't use -14 or even +14, whichever way you want to write your factors. Okay, because 14 is just too big. So I'm going to work with -27 or -7, 2. 1 times -2 makes -2. 3 times 7 makes 21. Now 21 is too big, so this is not a good pair. 1 times -7 makes -7. 3 times 2 makes 6. When we add these two together, it's -1. But we have a positive here, so maybe we need to switch these signs and make it +7, -2, and apply the magic cross. 3 times -2 makes -6. 1 times +7 makes +7. So when we add these together, we get +1, which is equal to the coefficient of z. So now we're ready. 3z plus 7, and the second one will be 1 times z, which is just z, minus 2. Now this one, 2, 1, and I see that this is -7. I could use 3, because 2 times 3 makes 6. I could put 1 here and plus 1, and that will make 7. Well, since this is -7, I could give negative signs to these two factors. So when we do the magic cross, 2 times -3, let's put a line here, it's -6. 1 times -1 makes -1. Add these two, -7. Yes. So we're ready to write our factors. 2 times c minus 1, 1 times c, which is still c, minus 3. For this one, I could do 6, 1, or 2, 3. And in this one, I could do 4, positive 4, negative 1, or positive 1, negative 4, or you could do 2, 2, and then the other one of these has to be a negative sign, or the other way around, negative 2 on top and positive 2 on bottom. So we're going to just work with some random pairs to see what works. 6 times negative 1 makes negative 6. 1 times positive 4 makes 4, and that's off. And 6 times negative 4 is negative 24. Now this is just way off. So I wouldn't use 6 for now. Okay, let's look at 2 and 3. 2 times negative 1 makes negative 2. 3 times positive 4 makes 12. Now 12 plus negative 2 is positive 10. That's still off. So we need to eliminate this one. Now here, 2 times negative 4 makes negative 8. 3 times positive 1 makes 3. 3 plus negative 8 makes negative 5. So we found the coefficient of negative 5. So 2, 3, and positive 1 and 4. Okay? So here we can factor 2y, 2y plus 1, 3y minus 4. Okay, now for this problem, you need to distribute the 4. So that's 12y squared minus 28y, and then plus 16 equal to 1. Now we need to set this entire equation so that it's equal to 0. Okay, so subtract 1. And then we can factor. Now this one could be a little tricky. We can have 12, 1, 2, 6, 15, negative 1 because it's a negative sign here, or negative 3, negative 5, or negative 3, negative 5. Let's just leave it for now. Now 12, I wouldn't use 12 because it's too big, okay? Like if you use negative 15 down here, it's like 12 times negative 15. It's just way off. So I wouldn't use 12 at 1. So 2 and 6, I will work with smaller numbers, okay? 2 times negative 5 makes negative 10. 6 times negative 3 makes negative 18. Ooh, negative 28. So here, negative 28 is equal to the coefficient of y. So after looking at all these problems, you'll notice that usually it's better to work with smaller numbers or smaller factors. Okay, so now we're ready to factor. So this will be 2y minus 3 and 6y minus 5 equal to 0. And by the zero product property, y could equal to 3 over 2 or 5 over 6. In this one, find the zeros of the polynomial function. So we need to let f of x equal to 0. And then we're ready to factor. Now this is, just use 3 and 1. And since this is positive 1 here, I think it would be good to use positive 7 on top and negative 2 on bottom. Because if you use positive 7 on bottom, you will get 7 times 3, which is 21. That's just too big. Okay? So by the magic cross, 3 times negative 2 makes negative 6. 1 times positive 7 makes 7. Positive 7, so that minus 6 makes positive 1, which is equal to the coefficient of x. So now we're ready to factor 3 times x plus 7, and then 1 times x, which is still x, minus 2. We can set that equal to 0, and then to solve this, this would be negative 7 over 3, or just 2. Okay, now solve the equation by clearing the decimals. So I'm going to multiply the entire polynomial equation by 10. So this makes 3x squared minus 7x minus 40 equal to 0. I'm going to use 3, 1 to factor. And for negative 40, I wouldn't use negative 40 as a factor or even 40 itself. So I'm going to use 5 and 8. Okay, and then one of them has to be negative. But 3 times 8 is 24. That's still too big, so maybe 8 on top and negative 5 on bottom. And I need to make sure that my signs are correctly placed after I do the magic cross. So let's double check. 1 times positive 8 makes positive 8. 3 times negative 5 makes negative 15. Now, adding these two together makes negative 7, which is the coefficient of x, so we're good. Now we can factor using 3 and 1 and positive 8 and negative 5. So that makes 3x plus 8 and x minus 5 equal to 0. So x equals negative 8 over 3 or 5. And for this problem, write a polynomial equation that has the given solutions. Then the equation must have integer coefficients. Now we could do this. X plus 3, x minus 2 equal to 0. Now, by the zero product property, these will be the solutions of this equation. Now, we can do the FOIL method, x squared minus 2x plus 3x minus 6, to rewrite this as x squared plus x minus 6 equal to 0. So this will be an equation with the solutions negative 3 and 2. For the word problems, I worked out the work for you to save time, so just follow along. An athlete throws a discus from an initial height of 6 feet and with an initial vertical velocity of 46 feet per second. So again, this is a projectile motion, so we need to use a vertical motion model. Part A, write an equation that gives the height in feet of the discus as a function of time in seconds since it left the athlete's hand. So f of t here, okay, t for time in seconds. So the vertical motion model would be negative 16t squared plus the vertical velocity here, initial vertical velocity is 46t, okay, plus the initial height of 6. So this will be your answer for part A. Part B asks you after how many seconds does the discus hit the ground? That's when f of t equals to 0. So I need to let f of t equal to 0 here. All right, and after I do this, I can simplify this by dividing the entire equation by 2. And then to get negative 8t squared plus 23t plus 3. And now I need to factor out this negative here. And then rewrite this as 8t squared minus 23t minus 3. Now we can factor this trinomial into a product of two binomials. So by doing the magic cross, I know I can use 8 and 1 and 1 and negative 3. So 8 times negative 3 makes negative 24. 1 times 1 makes 1. And this makes negative 23, which is equal to the coefficient of t here. So we can go ahead and write 8t plus 1 times t minus 3. And then to solve this using the zero product property, t would equal to negative 1/8 or 3 seconds. But we cannot have a negative time, so your answer is just 3 seconds. Okay, now let's look at this other word problem. You plan on making a wall hanging that contains 2 small mirrors as shown. Part A, write a polynomial that represents the area of the wall hanging. So I just took 2x and this 2x, added them together to get 4x. And I can take 2, 4, and the 2 here, and to get 8. And I'm going to add it together to get the entire height here, or width. So the area is represented by 4x plus 8 times this part, the length, x plus 2 plus 2, which makes x plus 4. So part B, it says the area of the wall hanging will be 480 square inches. Find the length and width of the mirrors you will use. So basically you substitute 480 in for A, and then you would have to rewrite the entire equation so that it's equal to 0. So if you look at the work here, I used the FOIL method to expand this two factors. And then I divided by 4 to make my equation simpler. So now that I have a coefficient of 1, it's easier to work with. So after I factored this, I get a product of two binomials, x plus 14 times x minus 8. How did I know to use 14 and negative 8 when I was given negative 112 here? Well, this is a good tool to use, the upside down division, so that you wouldn't have to like eyeball this. Okay, so you work this out very quickly and you'll see a pattern. Okay, so 14 plus negative 8 makes positive 6. So your x can be negative 14 or 8, but length cannot be negative. So x has to be 8 inches. And 2 times 8 makes 16 inches. So the length and the width of the mirror that you will use is 18 inches by 16 inches. And this concludes the lesson.